Hey guys, I have your notes here for section 10-2 day 2, and I promise these are going to be super short. I know 10-2 day 1 was super long, so I'll make this really quick. It's really just a repeat of yesterday. That's really all it is. So it's telling us to construct the sixth order Taylor polynomial. So we're going to find a polynomial that mimics cosine, and it'll mimic cosine better the farther out we go, but it's telling us to go out to 6. So that means we're going to do 6 derivatives. So I already did them. You all can totally do that without me. I did my 6 derivatives. I subbed in 0 and found the value of each derivative at 0. Now it's time to make my polynomial. Feel free to pause and copy that anytime. So for my polynomial, I'm going to start with f of 0. And then I want the value of my first derivative over 1 factorial times x to the first. The value of my second derivative at 0, 2 factorial x squared. Third derivative, 3 factorial x cubed. Fourth derivative, fifth derivative, sixth derivative. Simplify it, and just because it's kind of nice to see the pattern, you don't necessarily have to multiply these out. You can just leave them the way they are. Makes a cool little pattern. So that is a sixth order polynomial for cosine. It's going to follow the cosine curve out decently far. In your homework, you're asked to find one also for sine of x, and you'll see a cool pattern for the polynomial for sine of x as well. In fact, on the back of your notes, we're not going to write anything. I just want to point out, here's the sine curve. It's in blue. And this would be the first order, first order Taylor polynomial. And you can see how this is centered at 0. Yeah, it's a pretty good fit. The pink function is a pretty good fit at x equals 0, but the farther out you go, the worse it gets. Okay, so let's take our previous polynomial and add another term to it. And you can see that it fits it better. So this one was y2. Next one. For the next one, let's take our previous polynomial and add another term to it. You see it fits it better. Each time we add another term to our polynomial, the pink curve matches the blue curve better. And you can see what it looks like all the way out to the 9th order polynomial. I mean, that's pretty cool. How well it fits the sine curve. Okay, so that's it. That's it for your notes. Let me clarify what you're doing in your homework. You have a front-to-back worksheet, and you're finding Taylor polynomials for these functions. Each polynomial that you get as an answer, I want you to then transfer it to this sheet. This is going to be kind of a reference sheet that you're going to want to keep handy because you're going to keep referring back to it throughout the chapter. Write it in polynomial form and write it also in series form with a summation bar. And on the worksheet, I think it said to go out to the 4th. There were a couple of times on here that I might have gone out to like the 5th or the 6th just to get a better idea of like if I could continue the pattern, and I don't know, it just looked better to see a few more on here. Okay? Have fun with that.